This is lesson 7.2, similar polygons. For number 1, list all pairs of congruent angles and write a proportion that relates the corresponding sides for each pair of similar polygons. So, the corresponding angles will be congruent if they are similar. So angle A will be congruent to Z, angle B will be congruent to Y, and angle C will be congruent to angle X. And we also want to write a proportion that relates to the corresponding sides. So AB is to ZY, as BC is to YX, as AC is to ZX. So this is just relating the sides in corresponding order. Basically, if two figures are similar, then their corresponding sides will all be in the same ratio. For number 3, determine whether each pair of figures is similar. If so, write the similarity statement and scale factor. If not, explain your reasoning. So we need to check for two things. We need to first check to make sure that all corresponding angles are congruent. And on number 3, since these are both rectangles, we have 4 right angles, so all corresponding angles are congruent. And then the second thing, we want to make sure that corresponding sides are in the same ratio. So in this case, we have 4 is to 9, as 10 is to 18. And 10 over 18 would just simplify to 5 over 9, and obviously these two fractions are not equivalent. So for number 3, we would say no, since NQ over WZ is not equal to QR over WX. For number 5, each pair of polygons is similar. Find the value of X. So if these polygons are similar, then we can set up a proportion to solve for X. So 3 is to X, since those two sides correspond, as 4 is to 8, since those two sides correspond. So we can actually simplify this fraction to 1/2, and then cross multiply and divide. So if we cross multiply, we would take x times 1, which is x, is equal to 3 times 2, or 6. So x is equal to 6. Number 7, on the blueprint, excuse me, of the apartment shown, the balcony measures 1 inch wide by 1.75 inches long. If the actual length of the balcony is 7 feet, what is the perimeter of the balcony? Well, in this section, we have a theorem that states that the ratio of perimeters will be the same as the scale factor. So if we can find the perimeter of this rectangle first, so a perimeter of this scale rectangle right here would just be 1 inch plus 1.75 plus 1 plus 1.75 on this side. So that perimeter is equal to, let's see, 1, 2, 3, 4, 5.5 inches. Then we need a scale factor. So if the actual length is 7 feet, and in the diagram it is 1.75 inches long, so our scale factor is 1.75 inches to 7 feet. So then our perimeters will be in this same ratio here. So we can set up a proportion. So 1.75 to 7 feet is equal to perimeter 5.5 inches over x feet. And we solve for x, so we cross multiply. So 1.75 times x is equal to 5.5 times 7 . And then we just have to divide both sides by 1.75. So 5.5 times 7 divided by 1.75. Our perimeter is 22 feet. For number 13, we want to determine whether each pair of figures is similar. If so, write the similarity statement and scale factor. If not, explain. So for number 13, we have two triangles, and these two triangles are congruent by side, angle, side. Since we have a side here, an angle here, and the reflexive side would be marked. So triangle LTK is similar to triangle MTK, and that is because triangle LTK is congruent to triangle MTK. So if the two triangles are congruent, then that means that their corresponding sides will be in a 1-to-1 ratio. So the scale factor is just 1. For number 19, each pair of polygons is similar. Find the value of x. So since these two figures are similar, we can set up a proportion. So 2 is to 3, since those two sides correspond, as x plus 3 is to 2x plus 2, since those two sides correspond. So then just cross multiply. So take 2 times this quantity. So 2 times 2x would be 4x. And 2 times 2 is 4, and 3 times this quantity. So 3 times x is 3x, 3 times 3 is 9, and solve for x. So subtract 3x from both sides. So we get x plus 4 is equal to 9, and subtract 4 from both sides, and x is equal to 5. For number 21, once again, we would set up a proportion. So 8 is to x plus 1. As 20 is to 3x plus 4. And cross multiply. So we're going to take 20 times this quantity, so we get 20 times x is 20x, plus 20 times 1 is 20, and 8 times this quantity, so 8 times 3x is 24x, and 8 times 4 is 32. Then subtract 20x from both sides, so we get 20 is equal to 4x plus 32, And actually I made a mistake here. For some reason I wrote down 3x plus 4 when it was 3x plus 1, so let's go back there. Now when we cross multiply, we still get 20x plus 20, and we still get 24x, but we get plus 8. So subtract 20x, so 20 is equal to 4x plus 8. Subtract 8 from both sides, and 12 is equal to 4x, and divide by 4, and x is equal to 3. Find the perimeter of the given triangle, triangle DEF, if triangle ABC is similar to triangle DEF, AB is 5, BC is 6, AC is 7, and DE is 3. So my ratio of perimeters will be in the same ratio as the scale factor, so 5 is to 3 will be the same as the ratio of perimeters. So the perimeter of triangle ABC would be 5 plus 7 is 12, plus 6 is 18, is to the perimeter that we're trying to find. So we'll just call that x. Then if we cross multiply, we get 5x is equal to 3 times 18, and then we divide by 5. So 3 times 18 divided by 5 gives us 10.8 for the perimeter of triangle DEF. For 27, two similar rectangles have a scale factor of 2 to 4. The perimeter of the large rectangle is 80 meters. Find the perimeter of the small rectangle. So the perimeters will be in the same ratio as the scale factor, which is 2 to 4, which we can simplify that to 1 to 2, and then set up a proportion. So we have the perimeter of the larger rectangle, so that would have to go in the denominator since our larger number is in the denominator of the scale factor. And we're solving for x, so we cross multiply. 2 times x is equal to 1 times 80 divided by 2, and x is equal to 40 meters. For 29, list all pairs of congruent angles and write a proportion that relates to the corresponding sides. So we have angle A is congruent to angle V. We have that angle B is congruent to angle X. We have that angle D is congruent to angle Z. And we have that angle F is congruent to angle T. So if we wanted a similarity statement, we would have polygon ABDF is similar to polygon VXZT in that corresponding order. So if we want a proportion that relates to the corresponding sides, we would have AB corresponds to VX, BD corresponds to XZ, DF corresponds to ZT, and AF corresponds to VT. And for each of those, so let's just take one of those cases. So AB is 24 over Vx, which is 12, simplifies to 2. So we have a scale factor of 2. A shuffleboard chord forms 3 similar triangles in which angle AHB is congruent to angle AGC, which is congruent to angle AFD. For the given sides or angles, find the corresponding side or sides or angles that are congruent. So for 31, AB. And I think with the wording here, what it's looking for are the sides that correspond. They wouldn't actually be congruent, but that correspond between the similar triangles. So AB would correspond to, for this next triangle, as it overlaps, AC, and then that also corresponds to, in this largest triangle that overlaps, AD. For number 33, angle ACG would be congruent to these other two angles here and here. So ABH and angle ADF. Find the value of each variable. So for 35, ABCD is similar to QSRP, so we need to be careful to put corresponding parts equal to each other. So since we have an expression with x here for D, D has to be set equal to P, because those are both the last letters in the name. So we have x plus 34 is equal to P, which is 97. So if we subtract 34 from both sides, we get x is equal to 63. We also have an expression for y for angle R, and angle R is the third letter, so angle C is the third letter, so set those two equal. So 3y minus 13 is equal to 83. So we would add 13 to both sides, so 3y is equal to 96, and divide both sides by 3, and y is equal to 32. For number 37, you are using a digital projector for a slideshow. The photos are 13 inches by 9 1/4 inches on the computer screen, and the scale factor of the computer image to the projected image is 1:4. What are the dimensions of the projected image? So our scale factor is 1:4, which means that the projected image is 4 times larger. So if I take the dimensions here and multiply by 4, I should get the dimensions of the projected image. So I would take 13 times 4, which is 52 inches, and 9 1/4, or 9.25 times 4, which is 37 inches. So my dimensions are 52 inches by 37 inches. Determine whether the polygons are always, sometimes, or never similar. Explain your reasoning. Okay, so number 41, a trapezoid and a parallelogram. So a trapezoid has exactly one pair of opposite sides parallel, where a parallelogram has both pair of opposite sides parallel. So since these two figures are never the same shape, then these two figures are never similar. For number 43, two isosceles triangles would sometimes be similar if their corresponding angles are congruent and their corresponding sides are proportional. So visually you could have something like this. Here would be an example of an isosceles triangle, two isosceles triangles that are not similar, and then if I wanted an isosceles triangle similar to this one, it would look something more like this. So these two would be similar, these two are not. For number 45, two equilateral triangles are always similar because their corresponding angles are always congruent, because equilateral triangles always have angles of 60 degrees. And since all three sides are congruent in an equilateral triangle, then their corresponding sides will always be in the same ratio. For number 47, you are enlarging the photo shown at the right for your school yearbook. If the dimensions of the original photo are 2 1/3 inches by 1 2/3 inches, and the scale factor of the old photo to the new photo is 2 to 3, what are the dimensions of the new photo? So we can set up a proportion. So take a dimension of the old photo, 2 1/3, and that would correspond to a dimension of the new photo, which we don't know, which is equal to our scale factor here, which is 2 to 3. So we cross multiply 3 times 2 1/3. So 3 times 2 is 6, 3 times 1/3 is 1, so that would be 7, is equal to 2 times x divided by 2, and x is equal to 3.5. So one of the dimensions would be 3.5 inches, so we would do the same to find the other dimension. So take the dimension of the old photo, as it corresponds to a dimension of the new photo, and set it equal to your scale factor, 2 to 3. So we would take 2 times y is equal to 3 times 1 2/3. So 3 times 1 would be 3, 3 times 2/3 is 2, and 3 and 2 is 5. And divided by 2, and y is equal to 2.5 inches.